Okay. What are coalesce and repartitioning, and what is the difference between them? So another very important interview question. So you should know what is coalesce and repartition. But before understanding what is coalesce and repartition, let's understand what is actually a partition, right? So if you need to understand this coalesce and repartition, you need to understand what exactly is a partition. So we have a data frame, right? So let's say we have a data frame, the data is there. Now what happens is we can split this data frame into certain partitions. So let's say we have 100 million records. So you can split it into 10 partitions. Each one might be like 10 million records, right? And so each partition will have one executor. So why this is important? So if you have more partitions, right? So here in this case, we have 10 partitions, which basically means there is more parallelism. Parallelly, there are like 10 executors that runs, right? Fewer partitions, but at the same time, like what happens with fewer partitions, you will have fewer parallelism, but there will be less shuffle, right? So you might have to kind of shuffle the data into the different nodes for the partitions to take effect, because you might a partition, let's say you partition based on country, so you need to get all the data related to country into one particular node, right? So there will be shuffling. So this is the overhead that happens here. So basic concept, right? Now coming back to the coalesce and repartitioning, right? So now we talked about the partition, right? So you can increase the partitions, you can decrease the partitions. So both repartition and the coalesce function, they help in adjusting the partition. Okay, so that is what both of them does. So what repartitioning does is it it has the flexibility to increase or decrease the partitions. Okay, so there will be full shuffle that happens, but this basically has the capability where you can increase or decrease the partition. So you might have like 10 partitions and you might want to increase the partitions, you can increase it. At the same time, you might see like 10 partitions, that's way too many. You want to decrease this using repartition, you can decrease the partition, right? So that is what the repartition does, and it involves full shuffle. Okay, that is an important point. Coalesce, on the other hand, is only used for reducing the partition. So if you want to reduce the partitions, Coalesce is the one that you will be using with minimum or no shuffle, right? So this is again an important concept or important point that this happens with minimum or no shuffle. Okay. Now, if I look at certain features, right? So with partition, repartitioning, and the coalesce, so shuffling, yes. Repartition, as we see in the definition, it does the shuffling. So there will be shuffling involved. Increase the partitions, yes, you can increase the partitions. You can also decrease the partitions. So the performance would be a little bit slower, right? Because you will actually have the full shuffle, right? So we talked about the full shuffle. So compared to the partitions, the performance will be lesser. So if you want to just balance the data, so this is a use case. If you want to have a balanced data, this is what you can use for repartition. Now look at Coalesce. By default, there won't be any shuffle, but yes, there will be a little bit of shuffle, but comparatively to repartitioning, Coalesce will not have. Can you increase the partitions? No, you cannot increase the partitions. You can only decrease the partitions, right? Performance wise, it's much faster than the repartitioning because it has minimum or no shuffle. So that's where the performance gets into the picture, right? And what is the use case with it? So if you want to merge output files. So let's say you have like you are reducing the partitions, right? And you want to merge those. Let's say from 10 partitions, you have come to 3 partitions. So all those 10 files now has to be merged into 3 files, right? So that's the use case that we can have with this repartitioning, sorry, Coalesce. All right. Now, Let's look at an example as well. Like for example, let's take a scenario. Okay, so before we go to the code or an example, let's take up a simple use case, right? So let's say that you have a huge Parquet file. Okay. Now this could be any file. I'm just taking an example of a Parquet file, and it has 10 TB data, which is very big, right? And obviously, when you have a bigger data, we need to partition it. So let's say we did 50, let's take 500, okay? So we have like 500 partitions, okay? This 10 dB is, we have partitioned into 500 different partitions, okay? Now, we have done all the filtering and everything. So we have the filtering and everything, which is done, and we are left with 5 GB of data, which is very less, right, compared to the 10 GB. Okay. Now, how do you want to write this file? So you have a 10 TB input file, which has, we have 500 partitions, and now you have only 5 GB as the output. Okay. Now, if you keep this as it is, right, 500 partitions, so this 5 GB will get into 500 different files, right? Because that's the number of partitions that we have, okay, which is not good, because 500 small files, you will have too many files, and your performance will be, HDFS performance will degrade. Okay, this is not a good practice. You should not have too many small files. So this is where we can do this. We can reduce the number of files, right? So what we can do here is, instead of 500 partitions, so let's say the data frame is DF, what we can do is we can use Coalesce. Can use Coalesce, and we can specify the number of partitions that we want, number of files that we want, and then we can write it back to Parquet. Okay, so this is basically a use case that we have. So we have five, instead of 500 files, we are merging those output files into 10 files by reducing the partitions using Coalesce, right? So that is a use case. It's a real world use case that we can have. Okay, now let me also add another question to this. Okay, now this is fine, right? But let's say, what if the data is skewed? Okay, so some of these partitions can be very huge, some of the partitions can be minimum, right? Now, in that case, what we could do is we could use a repartitioning. Okay, so we could say a repartition of 10. So what it will do is it will basically shuffle the data so that the data is evenly distributed. Okay, again, this is another use case that we can use. Okay, so now let's understand this. I hope this is, the concept is clear, the use case where we are going to use is clear. So now we'll jump into Eclipse, and we will look at the code. Okay, again, a very simple code that I have written. You're reading all the Spark context, Spark sessions, and everything. So we have an RTD created. So we have the data here. We have an RDD where this is RDD, and then what we are doing is we are applying a coalesce. So basically, we are reducing the number of partitions. So initially, we started with 4 partitions of number 1 to 100, but then we are reducing the number of partitions here to 2. Okay. And then what we are doing is we are increasing the partitions to 8. So this is basically, the code is basically what I'm trying to show is how you are writing the code, how you can utilize the coalesce and partitions. Very simple. You just have to say dot coalesce and give the number of partitions, dot repartition, and just give the number of partitions that you want to use, right? We talked about we talked about the use case when you have to use the repartitioning, when you have to use the coalesce. This is simple execution of the coalesce. So you can see here is the number of partitions changed from 4 to 2, 4 to 8. So a simple concept. Code wise is all fine. right? So it's a very, very simple change. But the main thing comes where you want to use it, right? You cannot just go and, of course, you can go and just do a dot repartition coalesce or repartitioning, but please check the use case. When do you have to use the repartitioning? When you have to use a coalesce? This can cause a lot of issues if not used properly, right? I'm talking in terms of performance. Okay, so use this effectively, right? And we talked about the use case as well. So if this is a real use case as well. So when you have this use case, you could use Coalesce or repartitioning based on the type. Okay. All right. That is all I have for this use case, and I'll see you guys next session.